All right, next up, we're going to look at the variability of both the length of the arm and then the height of the rotation, essentially. So first and foremost, I kind of want to quickly go over some of the other mathematical options. And, quick disclaimer, I'm not all that good at math, but I know a little bit of the behavior of some of these trig functions that we're going to use here. But you'll see like people who are very, very good at math and calculus are able to create, forms entirely derived off of mathematical formulas. But what we're going to do is simulate the behavior of a sine curve. Okay, and it's super elementary right here, but it's going to allow us to create a sort of, a waving sort of sequence, and I used the term undulating before, perhaps incorrectly, but yeah, so it's going to kind of go in and out depending on how we want it to behave. So what I'd like to do is start off with generating that kind of behavior within a list of numbers. So let's go ahead and drop in, we're going to have to create a range of numbers. And so we can copy this information right here. And we'll just kind of pull it down off to the side here for a moment. Okay, so the range of numbers, I'm just going to start off with a list of a list of controls here. The way that I want to do this is I'm just going to say 1 to say 10. And then I'm going to need another panel here for the number of values. So I'll just put something like 20 on here to give us a fair number of values. So with this, I'm going to also very quickly create just a little exercise down here at the bottom. Okay, so what I'm going to do is use points by coordinates. So I'll go to, or not points by coordinates, construct point. Points by coordinates is a dynamo thing. Under vector point, we're going to do construct point. And so this is going to allow us to construct basically just a certain number of points and put them in space somewhere. So right off, let's go to the top view here. It'll be easier to see. Grid, hide. Okay. I'm going to space these. I have 20 numbers that I'm generating, and I'm going to, or 21 rather. I'm going to create an equivalent number of points. So I'll need to generate basically a number of points in the x direction. So that, in my mind, is going to require that I borrow the numerical property and multiply it and create a list of numbers. This part we're not going to need, so but this part we will down here. Let's just go ahead and do it. So under set and sequence, I'm going to create a series of numbers. And I'm going to create 20 numbers. I might have to do a +1. But the step size is going to be 1. And it's going to start from the number 1 or 0. It doesn't really matter. But that's going to be my x value. Okay, so you'll see that it creates 20 points in the x direction at a step value of 1. So the range of numbers that we've created here is 1, 1.45, 1.9. And so that, if you think about this in terms of generating actual geometry, if you plug that into y, you'll see that it starts to create a straight line going upward, right? So rather than having it go straight upward, what we want to do is be able to change the relationship across the curve and do something that is sine curve based. So if I go to math and trig and I pull in sine, take a look at, you don't have to drop a panel in yourself, but take a look at the two lists that it's generating. So there's this list right here, which is kind of a constant growth list, and then if I plug it into x for the sine, you can see that it behaves a little differently. It goes from 0.8 up to 0.99 to 0.94, and then it kind of goes downward a little bit, and it goes down to 0.99, and then it comes back up again to 0.99, and then it starts to go back down again, right? So this is creating a sine curve relationship, and you won't be able to see this very much in this exercise because it's too big, so I'm going to remap those numbers. So I'll go to Math, Domain, Remap. And then the numbers that I'm going to remap are the numbers that I'm reading in the panel right there. The source domain is going to be red using bounds. So I'll plug that in here. And then the target domain is going to be a new domain where I determine what angular dimension I want it to actually rotate. So if I want it to be, if I want it to kind of, go in a sine curve or rotate or grow, however you want to do it, I'll go from, I guess, we could do 15 and 15 again. I could do negative 15 degrees, positive 15 degrees, or negative 10, positive 10. I'll go with negative 10, positive 10. Just kind of try to delimit it to a 20-degree growth here. And then I'll plug this in, and you'll see that it's doing exactly the same thing. It's been remapped though to be 9.9, and then it goes down to 10.0, then it comes back up to 10.0, and then it starts to go back down again. So when I plug that into my y input, there's your sine curve. Now it starts at a bit of a funny position, but that is your sine curve. I don't know why it started there. And frankly, I don't know how to manipulate it to change it otherwise. 2 to 11. That's probably more appropriate. So yeah, it looks like I just shifted it left a notch. Okay. So essentially, what the number here is defining, if I change this to say like a 5, you see that the pitch of the sine curve grows. So it's the closer these are together, if this is going to be a 2, then it's going to be a straight line again. 3, 4, and in fact, if I just change this to a slider, for instance, that's going to be your basic arc, but let's make a slider 0 to 50. I have no idea what this is going to take, but you can see it start to grow and the pitch changes. But you can't even recognize it anymore. But basically, if you can just set this as a baseline, you'll be able to determine what kind of growth you want. So if you only have one, I forget what you call it at the bottom of the sine curve, the point at the apex of the bottom of the sine curve. It's been so long since I've taken a math class. Anyway, so this is the curve that I think I want, because I want it to start off relatively long, right? Because this is going to be the concave condition, so I want my numbers to be low in the concave condition. Then I want my numbers to be high in the convex condition. Yeah, I'll probably do it. Something like that. So 210, 211. It'll be close enough for what my purposes are. And then we can manipulate it later. But what I'm going to do, just sort of as an exercise, is to leave this on the side so that I can use it as like a graph tool that I can use to figure out what kind of settings I need for that particular sine curve. So anyway, let's go back into perspective. So we can use that to actually map into our definition. And we could use it to map into the actual rotation, or we could use it to map into the length of the arm. It's kind of up to you to define what that is, but what we're going to need for it is everything up to here. So I'll copy and paste and pull this up, group it. So I mentioned that these two are going to have to be replaced. Let me move this one down. And let me just start with the arm itself, the arm length. So basically I don't want my arm length to go a negative number. I want it to go a positive number. So I'll do something like a minimum of 8 feet. Yeah, minimum of 8 feet. And let's do like a maximum of 16 feet. It might actually grow up to about 20. And then when I plug that into my amplitude, actually it should match the same number of values there are. So this one has 11 values, and right now we're generating 21. So we want to reduce the number of values. So this number of steps is going to have to go down to 10. Yeah. So go ahead and plug that in to amplitude and make sure it's grafted. And there you can see that you've created sort of a sine curve in terms of the growth of each of those arms. Does that make sense? So that's how you get that kind of degree of complex variability. I know so far we've been using gradients, we've been using patterning. This is a little bit more in depth than patterning and stuff like that. Okay. So with that said, I think I want to leave it to you guys to incorporate this into your design, and then go on to the rotational value and do something very, very similar. Okay, and you don't have to feel restricted in the rotational value to having it, relate to the concave or convex condition. I want you to play around with it and see what it does when you start to play with the mathematical operations. Okay? Any questions? Simple enough, right? Okay.